Last time we went ahead and solved systems of linear equations, and today we are going to solve systems of nonlinear equations, which just simply means that at least one of the equations in the system is not a line. So we're going to jump right in because the process is the same as last lesson. So we're going to use either substitution or elimination depending on the problem and what seems easier. So for me, this one looks really well set up for substitution since y is already isolated. So I'm going to go ahead and plug that 3x plus 1 in for the y value. And then we're going to solve that. So I'm going to combine like terms. We get 3x equals x squared. Now, if you recall, anytime you see an equation with multiple x's, we're going to want to get that equal to 0. So I'm going to subtract 3x from both sides. So I get 0 equals x squared minus 3x. I do that so that I can factor and find my zeros from the factors. So I'm going to take out my greatest common factor of x, and I'm left with x minus 3. And I am now ready to find my two zeros. So I've got x equals 0, x equals positive 3. Now, last time we always only got, because we were dealing with linear equations, let me draw a picture. Anytime you're dealing with lines, you always got just one solution. But you're going to notice that we've already come up with two different x values. That's because if you think about what both of these graphs look like, this first equation, if you graphed it, would be a parabola since it's squared. And the second equation would be a line. So in this case, often with a line and a parabola, you get two solutions. You can get one solution, you can get no solutions because they could never cross. So it just depends on the equation and the line and everything. But in this case, we've got two solutions. So we're going to go ahead and find our y values for both solutions. So I'm going to go ahead and use this bottom equation. So for x equals 0, I'm going to go ahead and find my y by plugging 0 in for x, and that gives me 1. So one of my solutions would be 0, 1. So you do the x and then the y. And then for x equals 3, I'm going to find my y. So 3 times 3 plus 1. 3 times 3 is 9 plus 1 is 10. So another solution would be 3, 10. Now, it's always good practice with these nonlinear systems to check for extraneous solutions because some of them might have extraneous, some of them might not. And you just do that by plugging in your answers to both equations. Now, in this case, I found my y value by plugging into the second equation, so I can just check, and it's just good common practice just to double check anyway, but I'm going to go ahead and check by doing 1 minus 1 equals 0 squared for the first solution right here, and 1 minus 1 is 0, so that works out. And then for the second one, I'm trying to make sure that 10 minus 1 gives me 3 squared. Well, 10 minus 1 is 9, and 3 squared is also 9, so we know that one works. Okay, so I know it worked on the bottom equation as well, so we are good to go. Let's just jump right into another one. Why not? Okay, now on the previous problem, which I'll pull back up and have them side by side, a substitution method was really easy since we already had one of the variables isolated. Now, you could do substitution method for this. There are a lot of methods you could choose, but you could also do elimination. So if I did substitution, I would not solve for y. I also wouldn't solve for x. I would solve for x squared since both equations have an x squared. But I'm going to show you how to do this with elimination. So the x squareds have the same coefficient. I like to get the coefficients to match except one of them's negative. So I'm going to go ahead and multiply one of the equations by -1, both sides of the equation. So I'm multiplying by -1, distribute, so on. And since I'm doing the top equation, I'm just going to line it up right underneath this bottom equation. Okay, so we're just going to use these two. So So it's negative x squared plus 3y equals negative 7. And remember, when you do elimination method, so I'm using these two equations right here, you do want like terms to be lined up, or at least you just want to make sure you're only combining like terms. So x squared plus negative x squared, 0. 4 plus 3y is 7y. And 28 minus 7 is 21, or 28 plus negative 7 is 21. And this becomes pretty easy. Just divide by 7 and you get y is equal to 3. So in this case, we only got one y value. Now that doesn't necessarily mean there's only one answer. So let's go ahead and plug that y back into one of those equations. So if y is equal to 3, I'm just going to use the bottom equation. So I've got x squared plus 4 times 3 equals 28. 4 times 3 is 12. That's weird too, sorry. I'm going to subtract 12. So 28 minus 12 gives me 16. Then I take a square root. Now, careful right here. Most people, this is another classic blunder of this unit. Most people forget that you're going to have two answers right here. Remember, the square tells us there should be two x values. So don't forget there's a positive and negative answer. It's positive and negative 4. So there are actually two answers. We've got 4 and 3. Sorry, I was making sure I did my x first, then y. And then negative 4, 3. So the y value stayed the same for both, but one of the coordinates had a positive and one had a negative. And there it is. You can also think about the graphs, just so you know. So we've got two parabolas here, and one ends up being concave up, one gets concave down, so they kind of meet at some point, and you get your two solutions. So it's kind of cool. Let's go ahead and do another problem, because we're just going to jump through several problems. Okay, so elimination method or substitution method would work really well for this problem. Last time I did elimination, if I did elimination on, or so like number 2, but if I did elimination on this problem, I would eliminate the y squareds. I'm going to also show you how you can use substitution method for this, if you like. So this is just a method you can do. So I'm going to rewrite this to, and I'm solving for just y squared because there is a y squared in the other equation. So y squared is equal to 25 minus 3x. So I just subtract that 3x over. That means I can substitute 25 minus 3x in for the y squared. And there's no need to square it because both of these are equal to y squareds. So we got x squared plus 25 minus 3x equals 25. Okay. Now you would have had the same answer if you'd done elimination and you would have just switched the signs. You'll notice it doesn't look exactly the same. You'll see in a second how we'll get the same result. But let's go ahead and do the method I chose. So I'm going to go ahead and subtract the 25 over, which there's a 25 on both sides, so we just get it equal to 0, which is perfect since we have two variables, or two x's. And we're going to factor out our greatest common factor now that it's equal to 0. And then we'll find our zeros. So we've got x equals 0 and x equals 3. Now, at this point, we're going to go ahead and choose an equation to use to find our y values. So let's go ahead and start with x equals 0. I'm just going to go ahead and do the top equation, because why not? So we've got 0 squared plus y squared equals 25, which means y squared is just 25. And when you take that square root, don't forget you've got a positive and negative answer. So you got y is positive and negative 5. Which means, okay, good, making sure I had enough room. That means we have two answers. We've got 0, 5 and 0, negative 5 just from that one x value. So that's 2 of our solutions. Then we're going to go ahead and do x equals 3 and find those solutions. So we've got 3 squared plus y squared equals 25. So 3 squared is 9. Subtract that 9 from both sides. So y squared equals 16. And then I'll take that square root and you get y is positive or negative 4. So we have 2 more solutions. So we got 3, 4 and 3, negative 4. Now, good common practice, because sometimes there are extraneous solutions, which I'll give you a hint that usually happens when you have a square root in the problem, but there are other scenarios where you'll get extraneous solutions, so please just always check. Now, since I already used the top equation to find my y values, I've essentially checked those, so I'm now just going to go ahead and check by plugging into the bottom equation for both of those. So I just need to make sure, does 25 squared plus 3 times 0 actually equal 25? And it does, because 25 squared, my bad, 5 squared, which is 25, and that's 0. Then you just need to make sure that negative 5 squared plus 3 times 0 is also 25, which it is. And then this one, does 4 squared plus 3 times 3 give me 25? Yes. And then negative 4 squared plus 3 times 3. Just double check that it gives you 25. So you could do that in your head. Just double check and you'll be safe. So, all right, let's go ahead and jump to another problem, because why not? That's the real question. All right, so this one, you can do substitution, elimination method, whatever method you want. I'm just going to go ahead and do substitution because they're both equal to y. So I can just set the square root of x equal to 6 minus x. Now, fair warning, square root tells me there's a chance we're going to end up with an extraneous solution. So let's go ahead and solve. So I'm going to square both sides. Square root of x squared is x. Don't forget our classic blunder here, so make sure you FOIL this out. You end up with 36 minus 12x plus x squared when you combine like terms. And I'm going to go ahead and subtract that x. Because there are multiple x's in the equation, we want this equal to 0. So I have x squared minus 13x plus 36. And we'll now factor. So we'll get x minus 9, x minus 4. So the x equals positive 9, x equals positive 4. Sweet. Okay, at this point, let's go ahead and find our solutions for each one, or y values, I mean, for each one. So I'm going to go ahead and use the top equation. So y equals the square root of 9. Well, that's 3. So I should get the solution 9, 3. And we'll check that in a second. Let's go ahead and do 4. So x equals 4. So I'm going to put it into the top equation. So the square root of 4 is 2. So our other solution would be 4, 2. Okay, once again, since I used the top equation to test those, I'm going to go ahead and test them, or to find our y value. We're now going to check them with the bottom equation. So we're going to double check, does 3 actually equal 6 minus 9? Well, 6 minus 9 is negative 3, and those are not equal, which means this is actually extraneous. And then we'll do the same thing for the 4. So I'm checking the bottom equation. So 4 is equal to 6 minus 4. Sorry, 6 minus 2. I was about to say, let me test that. I keep saying the wrong thing. Let's try that again. 2, there we go, is equal to 6 minus 4. And 6 minus 4 is 2. So this one does work, and you keep it. That is the solution. Oh, wow, very nice.